algebra students, this is our introduction video for our lesson on equations and relationships. These last 3 lessons of this unit are going to focus on graphs of equations. This first part here is a review from what we learned in the past lesson. If you wanted to graph this equation here, we've learned if we want to use our formula that we learned back in pre-algebra, I can't do that right now. And so that first step in order to help me graph would be solving this equation for y. We did this in the past lesson, so go ahead, pause this video and solve this equation yourself. It'll help get you ready for today's lesson. If I want to solve this equation for y to change it into slope-intercept form, the first thing I would need to do is to get rid of the other term, which is that 4x. I subtract 4x on both sides, and that leaves me with negative 2y equals 12 minus 4x. Remember, you can't subtract these if they both don't have an x, if you've got a number and a variable. For our last step to get y by itself, I need to divide both sides by negative 2. I'm using division because negative 2y means multiplication, and I'm doing the opposite. And when I do that, I get that y by itself. Now, if I just copy down this big fraction, that's not going to look like slope-intercept form. I need those two terms to be separate. So I'm going to go ahead and do the division. This line going across means we divide everything by negative 2. So I do 12 divided by negative 2, which gives me negative 6. And then negative 4 divided by negative 2, that gives me a positive. 4 divided by 2 is 2, and so I get plus 2x. You can keep your equation like this, or you can go ahead and change it into the same order here by putting that mx first and then that b at the end. Once you've got this, we are ready to graph. Again, I encourage you, pause the video and graph this equation. It'll be good preparation again for today's lesson. I've got all my information labeled. I'm going to start with my y-intercept, which is at negative 6. I go to my y-axis and I put a point there at negative 6. And then my slope is 2. If I'm using rise over run, that means my line needs to go up 2 and over 1. So starting at my y-intercept, I'm going up 2 boxes and over 1. And I'm going to keep doing this to get enough points to help me graph my line there. I would encourage you to use a ruler if you have one nearby. And so this is where we ended our last lesson on, is one of the reasons you might want to solve an equation for a variable is to help you graph equations like these. The main idea of this lesson is connecting what we've learned about equivalent equations to what we know about graphs. The main idea is that equivalent equations have the same graph. We've said equivalent equations are equations that look different but represent the same story, represent the same solutions, and also represent the same graph. So for this first part, if you wanted to write an equation to represent this graph, I'm going to use that formula y equals mx plus b again, and that means I need to find my slope and I need to find my y-intercept. My y-intercept usually is easier for students to find. I go to my y-axis, and where does it cross? Right here at the number 1. Slope, remember you can use that formula rise over run to help you find that. If I wanted to find slope, I need any 2 points, so maybe these 2 points. And I'm looking at my rise and my run. So my rise, I see it's going up 1, 2, 3, 4 boxes and over 2 boxes. And 4 divided by 2 is 2, so my slope must be 2. So our equation could be y equals m is my slope, so 2x, and b is my y-intercept, plus 1. We've got this equation right here, represents this graph. That helps me answer the second question. If I asked you which other equation would have the same graph, that is just me asking you which of those equations below is equivalent to this equation. We're trying to find which of these 3 options represents the same thing as y equals 2x plus 1. We talked about equivalent equations 3 lessons ago. Go ahead, pause this video and see if you can identify which one is equivalent. When we had identified equivalent equations in that past lesson, we usually put them on top of each other like this and used what math we could find to help us figure out if they were equivalent or not. So for example, our first option A is the equation y equals 4x plus 2. When I compare our first equation, right, the equation I know is correct, to this one, I'm noticing that in order to change this equation to this equation, they multiplied one side by 2. We learned you can't do that. You can't only multiply one side. You would have to multiply both sides. So something like 2y equals 4x plus 2 would be correct. But this equation is not equivalent, which means it does not represent the same graph over here. In our second option, I noticed that they moved the 2x to the other side of the equation. We've learned if you want to move something to the other side of the equation, you always have to do the opposite. And so for me to go from this equation to this equation, it means they added 2x on this side to get the y plus 2x, but subtracted 2x on this side. You can't do different things on both sides of your equation, so that also helps me know this one is not equivalent and doesn't represent this graph. Now, based on what we talked about with equation B, looking over here, the biggest difference I see is they've got a negative 2x. So that means in order to get that negative 2x, they subtracted 2x on the left side and also subtracted 2x on the right side. 2x minus 2x would cancel out, which is how they got that 1 by itself, and then that negative 2x and the y give you this right here. You are allowed to subtract 2x on both sides, and so this would be an equivalent equation. And what that tells us in this lesson is it would also represent the same graph. We're going to be looking at more examples of this today and using this big idea that if the equations are equivalent, they would have the same graph. Thanks so much for watching.